Okay, so I'm sorry. Okay, so good morning, crewmates. Okay, so again, good morning. Welcome to our on-site participants here at PhilSA conference room, and also to our online attendees via Microsoft Teams and at the official YouTube channel of PhilSA. Welcome to the 8th HugNayan Space Science Forum. Okay, first of all, allow me to introduce myself to you. I'm Engineer Sandy Waikak Jr., a Science Research Specialist 1 under ISMDD, and I will be the Master of Ceremony for today's event. Okay, as a brief background for today's activity, the HugNayan Space Science Fora, which is organized by the Interdisciplinary Space Missions Development Division under the Space Science Missions Bureau, aims to expand knowledge of PhilSA personnel when it comes to space science and also share its wonders to a wider audience. Through this event, may we discover opportunities for collaborations and space science R&D. So as a background of the previous events of HugNayan, the first HugNayan was conducted last May 2023 and started with the inaugural presentation of Dr. Ian Vega III, a physicist who talked about black holes. The next HugNayan, our resource speaker, was Dr. Ronnie Concepcion II, an electronics and communications engineer who discussed topics related to sustainable agriculture using AI. The third HugNayan was presented by Dr. Gil Nonato Santos, a material scientist who shared his work on surface coating that could be applicable for space-related activities. And the fourth HugNayan that was conducted last July 2023, our research speaker was Dr. Ian Kendrick Fontanilla, a biologist who gave us indicators of life outside our own planet and the environments in which life could be supported. The fifth HugNayan that was conducted last August 2023, our speaker was Dr. Reynabel Reyes, an astrophysicist who discussed ethnoastronomy in the Philippines and gravitational waves. The sixth HugNayan, our research speaker was Dr. Giovanni Tapang from UP National Institute of Physics, who talked about doing it yourself or doing science independently. And last December 2023, our recent HugNayan, our resource speaker is Dr. Takuto Oikawa, an aerospace engineer from Astrobotics, a US-based tech company who works on building and designing rovers for lunar exploration. And for today, we have our very own resource speaker, Dr. Giovanni Serritella, to give the opening remarks and to introduce our resource speaker for today's event. May we call on the Director General of the Philippine Space Agency, Dr. Joel Joseph S. Marciano. Let's all give him a warm round of applause.
Thank you, Sunny. Can you hear me? Good morning, everybody. Good morning to the people in the room, to the ones viewing in their desks, and the ones online. Gandang umaga. We're very fortunate to have a very valuable speaker who come from the traffic, like everybody does. But then, let me say this. I have an introduction of our distinguished speaker this morning. I'll segue into that. But before that, our young agency, we're celebrating 5 years of the Philippine Space Act in Philippine 2024. In 5 years, you can look back at any 5-year period in your life, and you can try to think about the milestones that you've had in that span of 5 years. Maybe it changes over time, right? Not all 5-year periods are the same in a person's life. But for an agency, the first 5 years, that new agency, the first 5 years is really critical. It's very important that it takes the right steps, that it puts its best foot forward, that it doesn't really recline or rest back and say, well, let's just wait until, we're better, more complete, or we're in a position to do many things or to do things at all. No? Now, I think it's very important within that first 5 years of the life of an agency to really show its potential. Come out in the open and demonstrate things, maybe things that could still a little bit raw, but otherwise are already showing enthusiasm and promise of great results, no? And to whet everybody's appetite, and that's how these 5 years has been so far. No? We have gone out there. We have found a home, first of all, where we can now use as a springboard for continuing our work. And in that journey, we have received tremendous assistance from different groups. Tremendous help, in kind, moral support as well. And one of these groups, of course, is the European Union Delegation in the Philippines. The work that they have done really in helping our country, especially in this emerging space sector, started even before PhilSA was born in 2019. A few years before that, of course, they were engaging groups that were here, the DOST and Advanced Science and Technology Institute. And one of the very friendly faces, if you were there at that time, 2018, 2019, during those periods, one of the most friendly faces you will see and you will run into is the gentleman that we have here this morning, always ready with a smile. And I guess all diplomats perhaps are like that, but I don't know. But then there are diplomats that also have a very stern, formal aura to them. But our guest speaker this morning has really been exuding warmth and the generosity and enthusiasm that shows genuine appreciation for the work of space and entailed in space and the space agency and its challenges and opportunities and the great things that it can do for the country and for the world and for all of humanity. So on that note, I will now formally introduce our speaker this morning. Our speaker graduated at the University of East Anglia in UK, where he received a prestigious NATO Scholarship Award. He gained an advanced training in remote sensing and global climate change in University of Dundee, United Kingdom. He earned his master's degree in Cranfield University in environmental monitoring and climate change. His dedicated work for the environment was shown through his years in the European Union Delegation, where he is designated as the program manager to Indonesia, Albania, and the Philippines. He has made major contributions to several EU-funded projects in the field of environment, climate change, circular economy, and digital connectivity. And we're honored to be partners with the EU, together with DOST and the European Space Agency, in one of these initiatives, the National Copernicus Capacity Support Action Program for the Philippines, or COPPhil, which I should say is really a baby of our guest speaker this morning. The COPPhil, as you all know, was launched last year in April with a cooperation between PhilSA, DOST, and EU and ESA. It is the first space cooperation program in the region between the EU. And this new initiative will help our Philippine authorities develop national systems to make use of EU's Earth observation satellites belonging to the Copernicus program, the Sentinels, which you might be, I'm sure some of you are familiar with, for the country's disaster mitigation and climate change adaptation and food security strategies. So as our speaker is one of the personnel that brought forth, spearheaded, and gave birth to this initiative, crewmates, viewers, and friends, please welcome our very distinguished speaker for today and very good friend, Mr. Giovanni Serritella.
Thank you very much. Director General Marciano for this very nice introduction, and good morning to everyone in the room and online. Today, well, I heard from the speech of, from the introductory speech of DG Marciano that you already have had some speakers talking about astronomy in the previous events. So some of the concepts that I will illustrate today, they are not new to you probably, but my presentation will be quite generic. It will not go into so much detail. It will be much more of a way to share my passion for astronomy, which I cultivated since I was a child. I work for the European Union as a specialist on environment and climate change, and I manage the Copernicus program. That gave me an opportunity to revive my interest in space and build a relationship with the Philippine Space Agency and the DOST. So maybe we, I just wanted to have just a general presentation about exploring the universe and share some of my experience with some astrophotography and some instrumentation which I have in Italy and here also in Makati where I live. So maybe we go directly to the first slide. So as you saw in the brief video, we are all explorers, not only through satellite, through the International Space Station, but we are explorers in many ways. I mean, we explore, we are all driven by passion for the unknown, for the for space, for what lies out there, for the beauty of nature. We are exploring with our minds, not always through the means of technology. And astronomy is a discipline that helps us to activate this passion for the unknown. And how many of you, I mean, I'm sure many of you, like me, have been looking at the night sky, look at the stars and wonder how many stars out there. That's an impossible question to answer because the universe is does not have a fixed boundary, and we don't know how many stars are actually there. Other questions that we probably, please, maybe I can advance, yes, sorry, through with my eyes. Okay, just a small technical problem. Anyway, these are some of the basic questions that I'm sure many of us have asked ourselves. Thank you. How big is the universe? Is another question that is impossible to answer. The universe, as far as we know, is expanding, has been expanding since the Big Bang. It doesn't have fixed volume, or it doesn't expand into anything. We'll see later what this means. How old is the universe? That's something that we can answer. I mean, we know that more or less we are quite certain that it's about 15 billion years old, 14.8 probably. The universe had a beginning. We are quite sure it had a beginning in the Big Bang, but we don't know whether this is the only universe that we have, or if this is part of a multiverse, of many other universes out there. But we think quite confidently that this universe in which we live in started with the Big Bang about 14.8 billion years ago. Will it end one day? Yes. This is actually, we are quite certain it will end one day when all the fuel that is burned into the stars of the universe will run out, and then we will the universe will cease to glow, as so to speak. And as far as we know, that will be the end of the universe, but we will not be there anyway to witness it, so there's no problem. Then are we alone? I think you have already had an intervention and a presentation by another person about the possibility of life in the universe, and I think I will not dwell into that longer, but I will go straight into some pictures. This is my little personal astronomical observatory in Italy. That's my garden. As you see, I live in a rural countryside, in a very nice area. The beach and the sea is just behind those hills, and that's my little observatory where I spend many of my nights. taking pictures of interesting celestial objects. This is the dome as open. I cannot zoom in, but you can barely see maybe the telescope that is inside, and this one maybe shows it a little bit better. Yeah, I have a pointer here, but anyway, this was my first computerized telescope mount that I used, and it has two telescopes in parallel. I will explain later why we have two, because that evolved in time, and this is what my telescope looks like now. I have a new computerized mount. You see lots of cables that I should put a little bit of order in there, but it composed of my telescope is composed of several instruments. You see 1, 2, 3, 4. Now, the big one that you see is it has a particular configuration. It's called a Schmidt-Cassegrain telescope. It's used mainly for photographing galaxies and planets. Why? Because these are small, very small objects, and we need a high light collecting surface, the mirror of the telescope, and high resolution to capture the details of these small objects. The one, I'm not sure I can get the pointer to work, but anyway, the other one you see here is a refractor telescope. It's a lens-based telescope, and this is mainly used to take photographs of wide objects that take a lot of angular distance in the sky. This small one here is actually a guiding scope. Guiding because when you take astrophotography, you need to have a system, in this case, this motorized mount that follows the apparent movement of the star, of the particular object in the sky, following the rotation of the Earth. So the guiding scope will make sure that the object that is captured by this camera here remains right smack in the center of the sensor, of the camera sensor. So any small deviation due to slightly misaligned instrument or mechanical issues will be taken care of by this telescope with a guiding camera, which is this little camera here. You see other things here. Maybe this is a polar scope. It's an electronic polar scope. Basically, it allows to ensure that the mount is perfectly aligned with the polar axis, with the Earth axis, around which the scope will move. And then my laptop is there to control the telescope, and so this is fully computerized, meaning that this laptop here can be connected remotely to another laptop. And that's what I usually do in the winter when it's really cold and it's just too cold to stay in. Sometimes it's below zero in my dome, and I control it from the comfort of my living room in my house. But the exciting part is that we are discussing with DG Marciano possibility of running a little project, maybe to one day soon, to control this instrument through a laptop remotely here from the Philippines, and we can do that over the internet. So that maybe one of you who wants to take a picture of a particular object that you cannot see here because we are at different latitude, something that I can see in Italy, and you want to take a picture of that, you eventually can control and take a picture using my facility in Italy. It's something that we're working on. We can further develop, and you will be informed whether this actually materializes or not. This is some pictures. I will go quickly. Of course, this is the moon. This picture was taken from Makati. This also is a close-up using the bigger telescope that you saw. Some details of the craters of the moon. This is Mars. You can barely see. It's a little bit fuzzy. The reason being that planets in Italy at my latitude are very low on the horizon, and when they're low on the horizon, the atmosphere is thicker. So the planet, the light has to go through a thicker layer of atmosphere, and it gets diffused, and then it's a little bit difficult to get a very sharp picture. But eventually, it can be done. You can barely see the polar cap and some details of the surface. This is Jupiter, which I also took. Again, it's a little bit fuzzy, but it can be improved. The technique to take pictures of planets is actually you don't take a picture, you take a movie. You take a video, and the video is composed of many, many individual photos. And these individual photos, eventually a software will analyze those that are the best, and then they will stack them together, and you will get the final photo. This is Saturn. Also, it's very bright object in the sky, planet Saturn. Now, this is the Andromeda galaxy, which is a sister galaxy of the Milky Way, and this is what you see through a small telescope. You don't see these beautiful pictures with all the details. It's impossible because those details only become apparent when you take long exposure photos. So when you look through the eyepiece, all you see is a fuzzy cloud of, and that's the Andromeda galaxy. When you look through a larger telescope, like the one I showed you before, then you start to discern some details of the galaxies, of the stars around it. But then it's only through long exposure photo that you will get something like this. And this is a picture I took in the winter. The skies is much clearer, the air is cold, there is no turbulence. And what you do with these photos, basically you stack them together and you take this, get this level of detail. 200 billion stars, the Andromeda galaxy, 2 million light years away. I'm not, maybe you are familiar already with the concept of light years. Light years, of course, is a measure of distance, not a measure of time. This is just to indicate, how you can find objects in the sky. You need to be familiar a little bit with the various constellations and shape. The Andromeda galaxy is, you can see it from the Pegasus constellation going up a little bit. But of course, you don't have to do it visually, but a software will do that for you. It will identify the object for you. This is the same. Visually, if you go through a medium-sized telescope, you will see the Great Orion Nebula, a star nursery where stars are being born like this, just a fuzzy cloud. But then this is what I can see through the eyepiece. It's 1,500 light years away, meaning that the light that we see there left 1,500 years ago. We only see it now as it was 1,500 years ago, not as it is today. And this is what you get if you do a long-term exposure. And this, by the way, I took it from my balcony here in Makati, which is quite amazing considering the light pollution you have in Manila. But because now you can use special filters that block artificial light and only allow light of certain wavelengths to come through and go into the camera sensor. So this is the Orion Nebula taken from Makati. Through a binocular is you can still see it. It's one of the few objects in the sky you can see through a binocular. You can see it here. Actually, you can see a little blob. It can be exciting also just through a small binocular. Through a small telescope, of course, you start seeing more stars because you get more light coming in. And Orion, just a matter of curiosity, is in Greek mythology was a hunter. And I just want to draw your attention to this part. This is the belt of the hunter, and the sword, because we're going to see some pictures now taken in the area of the constellation of Orion. Now, this is what it looks like when you look up in the sky. That's you can barely make through the belt, in the belt here, and the sword, and the Orion Nebula is right in the middle of the sword. Near the belt, we have this very beautiful object, the Horsehead Nebula. Horsehead, of course, is called because it looks like a horse head. I mean, if you see that, in the middle you have this this shape, and if you want to find it, you see it's very near the belt of the Orion, as you can see in the illustration. And my attempt to take this picture in Italy gave me a very satisfactory result, which is this one. So this, again, I took it with my equipment in Italy, and I'm quite happy with it. You can see a lot of details. You can see the red. The red is basically hydrogen, ionized hydrogen, reflecting the light from nearby stars, whereas the dark part is interstellar cloud and dust that absorbs the light. Moving on, this is another interesting object, very easy to see, to spot in the night sky, is the Pleiades star cluster. Through a small telescope, small, meaning small, the one I have, you can see a little bit of that cloud, of the dust. Is about 100 young stars. Of course, you don't see all of them, but it's 100 million years old, 430 light years away. So this is what it looked like 430. This is my, 8 light years across. This is my picture of the Pleiades. As you can see, long-term exposure brings out a lot of more detail. This cloud that you see, this dust, I mean, it's not gas from the stars. Is actually a cloud of gas into which the Pleiades cluster actually moved into. So there was a lot of debate some time ago about whether this is actually from the stars, but no. In fact, this is a cloud of gas into which the cluster moved into. And then this is Omega Centauri globular cluster. Is a globular cluster composed of many hundreds of stars. Is the oldest globular cluster in the galaxy. It's taken also from Makati, from a balcony, using that filter, the specific filter that I mentioned to you. And these globular clusters are important because they're the oldest objects in the universe. They formed at the beginning of when the galaxy formed. So studying the globular cluster gives us insight into how the galaxy evolved and formed. This is 17 light years away. This largest globular cluster and 10 million stars. Some more pictures. This is the I go fast, the Triangulum galaxy, 2.7 million years light years away, also taken from Makati. This is a galaxy like the Milky Way. Is one of the sister galaxies in the local group. The Milky Way, the Andromeda galaxies, and the Triangulum galaxy is also part of the local group. 40 billion stars. This is another interesting object, is the Trifid Nebula, also taken from Makati. So you can see from Makati, you can actually, from the city, you can take very nice, interesting, high-resolution astronomy pictures. Emission plus reflection nebula emission because it emits radiation from the ionized hydrogen, and reflection is the blue part, basically the light that is reflected by stellar interstellar dust. This is the Tadpole Nebula, also taken in Italy. Tadpole is, you can see the two tadpoles, it's two stars being born here. You can get the details. This was taken with the smaller telescope that you saw because it's a very, it takes a lot of, it's a very wide object. And this also is the Heart Nebula. You can barely see the heart. Again, these are stellar nurseries. Stars are being born here. That's why you see a lot of this hydrogen gas are being ionized. This was taken in Italy. Okay, then I'll go briefly. I mean, this is something you already know, probably, I'm sure. This is solar system. Is 1.5 light years across. That Horse Head Nebula is 3.5 light years across. That means that our solar system can comfortably sit into the middle of the Horse Head because that looks like a small object, but it's actually very big. So to study astronomy, we need to, of course, to abandon the scale we usually use in the everyday life, because distance in astronomy are mind-boggling. I mean, to go around the Earth with a jumbo, it would take us 40 hours. To go to the moon, it will take us 16 days. And then if we take the same jumbo and we try to reach Mars, it would take us 9 years, for example, or Saturn, we'll go there in 147 years. So definitely, I mean, it's not at the best distances. And if you go to the closest star, it would take us 4.7 million years. So we need another another frame of another scale, another type of measurement. So that's the speed of light. The 300,000 kilometers per second. This is something you probably know already. So in terms of light years, I mean, if we could have a spaceship traveling at the speed of light, we will reach the moon in 1 second. Saturn from 147 years will become 1 hour. And so on. If we go to the closest stars, we can reach in 4.4 years instead of millions of years. But still, that gives us an idea that how big the universe is. I mean, the Milky Way, for example, is 200 billion stars and is 100,000 light years across. I mean, just the Milky Way. And then in terms of sizes, I mean, the sun, as you can see, in terms of comparison of size with the Earth, is extremely large. But then when we see the sun in comparison to some stellar giants like Betelgeuse or Antares, the sun is extremely small. You cannot even see it. So distances and sizes in astronomy are incredibly large, and our Milky Way, which was 100,000 light years across, becomes a tiny dot in comparison to this monster IC 1101, which is 6 million light years across. So we really tend to lose sense of scale. The Hubble telescope, when it was pointed at a specific area of the sky of the size of a straw, what did he see? He saw an incredible richness of galaxies. Each one of those galaxies is billions and hundreds of billions of stars and planets, and that was just the tiny size of a straw. So there are hundreds of thousands of millions of galaxies in the universe. I mean, just for us to appreciate the size. And stars, of course, are born and die. The sun eventually will become a red supergiant once it exhausts this nuclear fuel. Once hydrogen does not allow the balance, the star is in balance. The gravity tends to crush it together, but the nuclear fusion, hydrogen converted into helium, tends to expand the surface of the sun, and this balance eventually will come to an end, and the sun will expand to become a red supergiant. This will be what will look like Makati in a few billion years ago, and you can just see SM Aura there. I mean, but we will not be there. We can still enjoy going around and do some nice shopping. So eventually, after the expansion finishes, the sun will become a white dwarf. That's about the size of the Earth, with the matter extremely compressed, where the 1 cubic centimeter of matter will weigh about 5.5 tons, the size the weight of an elephant. Then stars which are more massive than the sun, about 5.5 masses of the sun, actually explode into these supernova explosions, which are they disseminate the seeds of life in the universe, because through this is the Crab Nebula, which is a remnant of the supernova explosion, because inside the stars the heavier elements are synthesized, like carbon, oxygen, magnesium, silicon, and so on, and these are building blocks of life. So these supernova explosions, in fact, are very important to disseminate these building blocks of life in the universe, and from the fragments of these explosions, eventually planets become they come to be born, like the Earth, for example, and eventually we go from this to this. So this is eventually, well, some stars which are more massive than the sun, instead of after a supernova explosion, they become black holes. You already had, I understand, an introductory presentation on black holes, so I will not go into that. Okay, so this was what we think is the beginning of the universe, a singularity of infinite density about 14 billion years ago. There was no space, no time. I mean, you cannot say that at the time, what was before the beginning of the universe? There was no before, there was no time. Time actually started at the Big Bang. And this incredibly fast inflation happened, which eventually gave birth to planets with life like ours. And then we come to a point where we start to question how it came about and why. But why is a question that science is difficult to answer. So that's where we enter the realm of science and religion. I mean, it's difficult. Is a difficult area. There's a lot of debate going on whether the universe actually shows some design, underlying design, or whether it's completely part of chaotic chance. Now, the famous Stephen Hawking mentioned that because the gravity, there is a law of gravity, there is gravity, and that's how the universe comes about. So he completely ruled out the possibility of design, of intervention from a supreme designer. On the other hand, the Nobel physicist Richard Feynman, he says that because there are rules like gravity, it tells the possibility of prediction. I mean, he said it tells you what you would expect to happen in an experiment you have not yet done. So he tends to infer of possible underlying design. We actually don't have an answer to that. So the debate is open, but it took 4.5 billion years for us to exist, from the Big Bang to intelligent life. And this is the universe that looks at his origin. The eye looks at the tail, basically looks back. And so I tend to think that as much as we are small and insignificant, we are still extremely important, because through the human brain, we develop, the universe develops self-awareness. So it can look back at its origin, understand it, and study it. So I think, and because intelligent life is so difficult and so rare and so extremely unlikely, that's why I think that the human beings are extremely important in the context of the universe. So, as I said since the beginning, now we go back to the beginning, we are explorers. We just, we've gone quite far from being exploring the universe, like thinking of a universe like a sphere with all the stars and then going around the Earth. So we've done quite a lot of progress into that, but we are still exploring. We still try to understand and appreciate more the universe around us. And this is my last slide. That's the famous picture of the pale blue dot. That's the Earth, taken by Voyager 1 in a sun's ray. I mean, that's what Carl Sagan, the famous astronomer, said. That is here. That is home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. And that's where we are. That's all our history, our advancement in science and everything. It's all in there, in that little dot. And as far as we know, there is nothing like that in the universe, as far as we know so far. So it really comes down to our responsibility as human beings to protect this unique jewel of creation. Let's put under inverted commas, creation, and to ensure that this is protected and handed over safely to future generations. And with this, I conclude my presentation. Thank you very much. You're most welcome to contact me at the mail address you see there if you have a question, or you can raise some questions now if you wish. I'm happy to answer. And I hope to see some of you remotely connected when I'm back in Italy with my telescope. We'll try to have some fun and take some of those pictures. Maybe you can take them remotely from here.
Okay, so thank you so much, Mr. Serritella, for your educational and inspiring talk and sharing your passion and knowledge about astronomy and astrophotography. I hope everyone here and those who joined online has learned something new today. Now we are opening the floor for questions. Please introduce yourself and the division or affiliation. And also to our online viewers, you can also drop your questions in the comment section and we'll come back to check on you later. So any questions from the audience?
First of all, let me say thank you very much, Giovanni, for your very brief but informative presentation. I don't know if that's what you expected when we invited a member of the European Union delegation in the Philippines here to PhilSA to talk about, but it really just shows. I'm still trying to think of a question. I just want to add something, but it just shows how there are things that we do and there are things that we love, right? And sometimes they happily go together. But then, that's the quest, right, of life is things you do, things you love, manage. And certainly, I think we've seen what Giovanni does in his day-to-day work, and that's been very helpful, especially, as I mentioned, to a young organization like PhilSA. But we've also gotten a window to what Giovanni's passion is about, and it exudes. And we want to thank him because even as I failed to mention it, I guess maybe you know already, but he is leaving the Philippines at the end of this month. And he's ending, how many years in the Philippines, Giovanni? 7 years of kind of tour of duty here in the Philippines. And so then it is not a reassignment, it is actually a retirement. It's a early retirement. So then I would not blame you if I go back to a place like that, and then I would and then do that sort of thing. But yeah, so he's leaving at the end of the month, and we thought maybe we could have him speak to us, and you could all meet him before he leaves, and give him an opportunity to offer what he has. He's made a lot of friends here in the country, and I think it's good that he would like to continue that linkage with people here, especially young ones. I should add that this Friday I am having a guest. He's the deputy governor of the Central Bank of the Philippines, and he told me, do you have an observatory, because my 14-year-old son is an amateur aspiring for astronomist. And I said, well, you know what, I have in Italy there is one. I know. But one more thing. Okay, so let's all promote that opportunity, and I hope some of us could personally take advantage. There's another thing that, during the Space Ecosystem Core last December, Giovanni was there, and we thank him for joining us. He made it a point for us to bring him to the Pag-asa Observatory in the campus. And he saw it, and just like anyone passionate about telescopes, he took pictures, shared pictures with us. Unfortunately, that telescope is not working. But we're trying to see how we can help each other, Pag-asa, PhilSA, UP, and certainly, and well, Giovanni, who's been very generous with his time, has also offered some insights on how a program perhaps can be conceptualized and proposed that could make that telescope functional again, and perhaps find back its glory days and even better days. So I just want to share that with you. Giovanni can probably talk about it some more if he's comfortable about that. But then my question is this: how did this all begin, Giovanni? How did this, this telescope in your backyard, and can you tell us a little bit about that story? Thank you.
Thank you, Director. How it all began actually is through a book. My parents gave me a book when I think I was probably 9 years old, 10 years old. And in this book, there was a section on the solar system. So I look at the Earth, Jupiter, Saturn. I say, oh, wow, this is amazing. My imagination as a child was immediately started going through these planets and think, oh, what is there? Why there are so many planets? So that's how the interest came, and that's why I think your initiative of launching the book, the children book, is very good. because it really, at that age, the imagination and the creativity of the children is fantastic, and I hope through that initiative you will have some good space scientists one day that will have the same interest as I did in astronomy when I was a child. And in terms of telescope and instrumentation, it all started after the book. I became interested. My parents gave me a toy telescope, on which I used to spend hours looking at from the window, at the moon and the craters, and then eventually I started going deeper into the discipline, and I purchased the as you saw the first picture in the first equatorial computerized mount. Then eventually was upgraded to the next level, and with addition of other instruments and so on. But those pictures of my telescope is a composition of different instruments bought in different parts of the world, from Singapore, from Italy, from Germany, and I put them all together in Italy, and then that's now it allows me to go deep into the space and appreciate these beautiful objects. When I look through a telescope, I still have the thrill as if I was a little child. When I see these dots in there, and it feels like it's amazing. But it's something that maybe not everybody has, but that's how it started for me. Yeah.
Do you have any?
Hello, Giovanni. Thank you very much for your talk. I'm Norris Castillo from the Space Policy and International Cooperation. I believe we met before, but I would like to ask, what would you suggest to someone who is interested in going into this as a hobby, not necessarily as a career? How would that person start?
Yes, thank you for the question. This is a good question. In fact, my idea initially was to become an astronomer, but then I took a different path, and I ended up studying about the environment and landed in the European Union 21 years ago, managing projects about forestry, but the passion remained about astronomy. And the best way to approach astronomy as a hobby, I think, would be first maybe to join a local association. Like in the Philippines, there are a number of youth associations and organizations. They organize stargazing events, and there you get to know people. You start to see the telescope. You see that, you realize that you will not see those beautiful pictures through the telescope, but you only see these fuzzy objects, and that hopefully will stimulate your interest in learning more. How can I actually get more detailed, more beautiful pictures, if you are interested in astrophotography. If you want to learn more about the other areas of astronomy, of course, yes, you can find a lot of information on the internet, and some good books, lots of good books around. And if you want to start, you can find reasonably priced telescopes, which nowadays, with the help of technology, become so user-friendly. You just really have to press few buttons, and the telescope does everything for you. You just need to polar align it properly. Means you need to find it's a bit difficult in the Philippines because the North Star, which is like a reference point, is very low. Is only 15 degrees on the horizon. So you see the polar star, you see very, very low. And as I mentioned before, when the star or the object is low, there is a lot of atmospheric turbulence and interference. But basically you have to align your telescope in a way that the mount is aligned with the Earth axis, and then you can take some long exposure photos. And as I said, there are some reasonably priced telescopes nowadays that can do that for you, and they can even correct if you're not properly polar aligned. Yeah, there are different ways in which you can approach your hobby. Yeah, but the good entry point would be to join maybe one of the local groups, associations. Yeah.
Any other questions?
Hello, my name is J.M. Plaza from the Office of Deputy Director General. My boss is KJ Perez. Actually, I'm interested in the long exposure because, well, I did have a telescope when I was a kid, and that was like a toy. But I believe when you use long exposure, then you'd you'd let the telescope be exposed to the celestial body for quite some time. Do you have software applications where that would automatically adjust, or do you have to manually? And then this that is it limited for one night, or could you continue the long exposure the other day?
Yeah, the software is really fundamental because it controls the mount, it controls the telescope, it controls the camera. It you tell the software how many photos you want to take of the object. Depending on how stable your mount is, you can expose, for example, an object for 30 minutes, but not 30 minutes continuously, because 30 minutes continuously might end up giving you too much light on your sensor, and it might burn out the picture. So what you do, you take maybe a 5-minute exposure, and another 5-minute exposure, and another 5-minute exposure, and another 5-minute exposure, and then you stack them all together. And the software can do that for you, of course. Nowadays, there are softwares that are very user-friendly. I mean, they can even control everything. I mean, it's just, you just need to familiarize with it. And in terms of, yes, you can do that sequence in one night and go back the next night and continue, and then go back the next night and continue. So you can build maybe a 2-hour exposure and get a lot of details by combining all these different sequences together. And in one night, of course, it depends also on how long you can see the particular object before it disappears behind maybe a building or a mountain. Yes. But yeah, you can combine them all together. Yes.
Thank you.
Any other questions from the audience?
Yeah, hello, I'm Lois Andayal from the Office of Director General. Thank you so much for your presentation. And of course, what DG said a while ago, you have lots of experience. And I'm not sure if I got that correct, like the retirement thing. So I just want to ask, like, if there's one takeaway from all those years, what will it be? And like, how did it shift your perspectives, like from starting and now going there?
Thank you. You mentioned those years in studying astronomy, or those years in the Philippines. I didn't quite understand the question.
Okay, so my question is like, after all those years, like, what is like one takeaway if you would pick, and how did it shift your perspective when you were starting, and then now you're, I'm not sure if that's the case of like the retirement thing.
Yes. Okay, well, what I learned over the years is that the more you learn, the more you want to learn, and the more your interest expands in other areas. That's why I put those few slides about science and religion, because I think especially astronomy is an eye opener into possibilities of meaning. There is meaning actually in the universe, in nature, built in nature. I see an incredible complexity in the universe, in the biological world, and I think what changed my perspective to start expanding more beyond just taking simple, beautiful pictures of object was a first debate that I witnessed between an Oxford mathematician who is also a very religious person, and the professor who's no longer alive anymore. I mean, he passed away, but he was a brilliant scientist who was an atheist. And I watched the two debating, and it was just incredible, fascinating. Both of them make perfect sense what they were saying. So at the end, there was no winner between the two. One advocated for a universe that had a beginning and a designer. One advocated for, like I said before, like Stephen Hawking and Richard Feynman, the two opposite views. And that debate kind of made me change a little bit of my perspective in life. I'm not a very religious person, but I'm a believer. And I think astronomy helped me to consolidate my my faith, my belief, instead of make me go away from it. Because again, it was that particular debate that I witnessed that really made me appreciate more and wanting to learn more about this discipline. Yeah.
Any other questions from the audience? Okay, so yes.
So I'm just curious about your setup in Makati. How do you, what's your setup there, and how can you describe it a bit for us? Thanks.
Yes, unfortunately I don't have a photo of my setup in Makati, and now everything is packed in a box, because in 3 weeks' time I will be leaving. But it's a simplified version of what you saw in the picture. Is a computerized telescope mount with a solid tripod. That's very important, because if it's wobbly, then your pictures will be shaky and you will not take good pictures. So the most important thing is to have a solid tripod and a solid computerized mount. And then I have here just two telescopes, like you saw there, in parallel, smaller than those, which I took one for the planetary photo, one for the galaxies and the wide objects. And all this can be assembled in 15 minutes. I mean, the problem is that on my balcony, I don't see north. So how am I going to align my telescope with the North Star when I don't see it? And there is a technique for that. It's called drift alignment. Basically, you need to look at some stars. You have to see how. Okay, what you do, you take a compass, and then you draw an imaginary line on the floor where the north-south line would be. That more or less you align your telescope like that. That's what I did. And then you start looking at stars. If they drift in one direction, then you have to move the mount in the opposite direction. If you move it in the other direction, so it is a process that takes a little bit of time, but eventually you can align your telescope even if you don't see the North Star. And you can do that if your mount is not so big and not so bulky, not so heavy. Like that one is fixed on a pillar. This one is a tripod. You can move it around a little bit. I don't have a picture, I'm sorry, but yeah, those pictures I guarantee were taken from my balcony. Yes.
We'll take one last question from the audience.
Hello, thank you. Thank you for the presentation. I'm Arlo from the Space Data Mobilization Division. So I came across an interesting article just recently that they found a star older than our universe. So I'd like to ask, what's your take on this? Or is it an error, or maybe there's things that we've yet to understand?
My answer is that I don't have an answer. I'm sorry. I also saw that I don't really know how to interpret that. I don't know whether it's because of maybe uncertainties in the measurement of the age of the universe. But a star that is older than the universe is something really mind-boggling. I don't know how to explain it, because stars before, I mean, after the Big Bang, it took several million years before stars actually light up, because they have to, the whole hydrogen that was there had to come together, and then when it reaches a certain pressure, then that's when the fusion of hydrogen atoms happens and to form helium, and that's when the star actually lights up. So in order to have that, you need to have a medium, you need to have hydrogen, you need to have something So I don't know exactly how this star, older than the universe means, but it's something I don't have an answer. I'm sorry.
Thank you.
Um, the pictures that that you showed here, I wonder, what are your plans? Do you plan to publish a book or a booklet, or you want to compile that? Because all of a sudden I'm thinking maybe we should um, get all of these contributors and publish some kind of a book that we compile, the universe viewed from Makati or from the Philippines. Something like people don't really expect that, that it's possible. So people can be inspired. Do you have any plans for these images?
I don't have any plans, Director, but I'm very happy to share these pictures if you plan to put together something like that. I can send these pictures electronically, no problem. It can be published. There is no copyright. The space, as you know, is for everyone. So those objects belong to everybody. So I'm very happy, actually, if you can. Yes.
So we'll take you up on that once you settle back in Italy, in Ancona, and then we'll contact you through that email. Just one last thing. Have the Starlink satellites ever bothered you? Well, can you talk a bit about that?
Yes, uh, indeed, yes. They are a bit of a nuisance. But the good thing about these softwares and nowadays the help of technology, as I was mentioning before, you can take several sequences of many pictures, and then you discard those with a satellite trail. So yeah, sometimes you have these lines, in the middle, but what you simply discard the picture and
Did you keep some of these pictures? Because they might also have some value in terms of looking at how they mess up a picture or whether,
I probably have in my laptop in my hard disk. Maybe I have some discarded pictures. Yeah, with this. So if I find them, maybe I can share them. Yes.
Okay, well, that's all. Thank you so much, Giovanni.
Thank you very much.
Okay, so with that, thank you, Mr. Serritella, for your time and valuable insights in space science, technology, and applications. To give the tokens of appreciation and awarding of the certificate, may I call upon Director General Joel Joseph Marciano Jr. and Deputy Director General Dr. Gay Jane Perez together with Mr. Giovanni Serritella in front. Let me read the citation. Republic of the Philippines, Office of the President, Philippine Space Agency. Certificate of Appreciation is hereby awarded to Mr. Giovanni Serritella for sharing his expertise and knowledge as resource speaker during the HugNayan Space Science Fora held on January 8, 2024. Given this 8th day of January 2024 at Philippine Space Agency, 11 Eastwood Avenue, Bagong Bayan, Quezon City. Signed, Dr. Gay Jane P. Perez, Deputy Director General for Space Science and Technology Applications, and signed by Dr. Joel Joseph S. Marciano, Director General, Philippine Space Agency. Happy Okay, so thank you so much once again, and let's all give another round of applause for Mr. Serritella. Before we formally close the program, may we call on the Deputy Director General for Space Science and Technology, Dr. Gay Jane P. Perez, for the closing remarks.
Thank you, Sunny. Um, so indeed, we were very fortunate to have Giovanni join us on this first Cosmic Kapihan of the year. Just when you thought the new year is over, then you start seeing more fireworks. Of course, not fireworks, but galaxies, stars in front of us. So it couldn't be more fitting than having Giovanni in this Cosmic Kapihan. And I think it's also, you can't help but be philosophical when you start seeing these things. And I guess it really put more meaning to what we are doing here at PhilSA. It shows us that there are a lot that we still don't understand, a lot that we still can explore. And I really like this cartoon, the U cartoon with an eye and looking at the tail. I actually took a photo of that to remind me, because that's really what we are doing here. We are trying to understand more about ourselves by looking at the distant past, and it's truly mind-boggling, to piece these things together. And with that, I just want to end this HugNayan with a challenge to everyone to continue exploring, continue asking questions, continue searching, because there are surprises out there. We don't know what it would be, but it's really something that we can all look forward to. So with that, thank you, everyone.
Thank you very much, DDG Gay, for your message. Now we have finally reached the end of our program. It has been a great day and a wonderful morning with all of you. Thank you for all your participation. And I'm also inviting everyone, all of our attendees here, to join us here in front for the photo opportunity. And also for those who are online attendees, you may also turn on your cameras. So let's all come in front po for a picture. Okay, so for all our on-site attendees, do not forget the evaluation form that will be flashed in the screen. And again, do not forget for us to evaluate regarding the today's Ugnayan. You may also get your lunch outside the training room. We have also reserved the room until 1 p.m. And again, before that, please answer our short evaluation form so that we can further improve our HugNayan Fora. Again, the QR code has been flashed in the screen. So I request again everyone to kindly evaluate. Thank you, and to all our online viewers, we'll now be signing off. Once again, good afternoon.